Hey up everybody, welcome to Yorkshire Fab Shop. So as you've just seen today, we're going to be making a motorised T-mover. Nah, just kidding. We're going to be doing a linear welding positioner, welding carriage, motorised welder, whatever you want to call it, all the same thing. And the idea of the project is basically to keep costs to a minimum, if not zero. So as much scrap, as much rubbish, anything you've got lying about, anything that you're going to throw away or is out of your scrap pile, that's what we want to be using today. So before we go into the finer details, a couple of tubes, bit of stud bar, a couple of rusty bits of box section, DC motor, a couple of pulleys, basically stuff that were just in the bin or not going to be used for anything else. So if you stick with us, we'll go through the materials, I'll show you how to throw it together, and we'll show you it working. So hope you enjoy. Right then, okay, so let's take you through the materials we've used for this build. We get the technical stuff out of the way. Apologies if it's an issue, but it's a typical Yorkshire evening tonight and it's absolutely freezing in the garage, so apologies if all you can see is my breath. Hopefully it's not steaming the lens up on the camera, but anyway, typical Yorkshire, will crack on regardless. Start with the housing where the motor, DC motor control is going to sit. 3mm plate, because had it. 2mm will be fine. 4mm will be a little bit overkill in my opinion, but if you've got it, use it. So 3mm, perfect compromise between strength and weight. It's easy to manage. You'll be able to cut it with a slitting disc on a grinder, no problem, or a bench shear. And then welding, again, you don't need a big powerful welder to stick 3mm together. We've got a 12V DC rear windscreen wiper off a car, worm and wheel drive gearbox in there, so it's very powerful for its size, nice and slow, although maybe a bit too slow. I've done some calculations on the output speed, so I'll show you them in just a minute, but with a bit of luck it'll be alright. We've also got a couple of pulleys off an old bench drill. You can sit something like that with its belt, of course, because it'd be useless without. So onto the lead screw. This is 3/4 inch BSF thread form. Obviously completely redundant these days, BSF Whitworth. So it's an ideal candidate for this project. Unfortunately, with it being BSF, it's got a little bit of a finer thread than I was hoping. M20 would probably be better. But I had it and I weren't going to use it for anything. I'd sooner use this than a piece of M20, to be honest. So I thought it'd be a perfect opportunity to get rid of it because I've got no other use for it. And that's where these pulleys come into their own, because I estimate the output speed of this motor to be about 80 revs per minute. However, that on its own would be too slow with this threaded bar. I did a couple of quick calculations, and 60 RPM with a 12 threads per inch thread count, which this has got, will give me a travel speed of about 5 inches per minute, which for what I'm going to be welding is miles too slow. Pulleys, I'm hoping I can use the increase in speed, because if I use the biggest to smallest, I'll get a double in speed output. So that'll give me an effective output speed based off about 80 RPM, will give me 160 RPM, which will put me around 13-14 inches per minute of travel speed, which again is too slow. However, by maybe using 14-15 volts, provided the motor survives, I will get somewhere near to 20 RPM. Rails, we've got some 40mm outside diameter, 3mm wall thickness tube, but onto the carriage system. So we'll start by showing you this. This is a piece of box section, or it was. I've sliced it down diagonal to give me 2 pieces of angle. I didn't have any angle this size when I got big stuff, so I had to make use with what I've got. Obviously, that's the idea of this project, use as much scrap as you've got lying around to get rid of it all. So they're going to sit there and there. And there we're going to be able to slide up and down, no problem. So for the carriage, for the MIG gun to mount onto, I'll I'll have some sort of joining piece of plate, piece of box section, piece of angle, whatever I can find. And to mount the MIG torch, it'd be nice if I could have some articulated joints on here, but we'll see what we've got left over at the end of the project. So that's going to sit there. Hopefully I'll be able to adjust the angle if I'm doing a fillet weld or if I'm running along some plate or something, and then I'll be able to adjust the angle whether I'm pulling or pushing to give me full range of adjustment on there. So again, we shall see what we've got left, but with a bit of luck it'll all come together. So let's go stick it together and see how it works. Okay, let's discuss this motor in a little bit more depth. Mentioned earlier, its output speed were about 80 RPM. That were a wild guess, purely a guess based on seeing it running on a battery. I've no idea what its exact output speed is. Now, it had me up all night. Couldn't help but thinking it isn't going to get me the travel speed that I'm wanting. So I thought, I need to get it powered and I need an accurate voltage. So I haven't got a DC motor controller here, unfortunately, but I have got the MIG welder. So I thought, let's get it hooked up to the MIG welder and let's see how fast it spins. I've got an RPM gauge, so I can measure it accurately. And let's have a look to see if it's going to be fast enough. With a bit of luck, it won't weld itself to the bench. So. Just kidding, I'll do it for real now. Okay, so I've got the welder set up. I've already got the voltage set, but I've got the multimeter on the go. So that's 20 volts, but that's open circuit, don't forget. So when it's running, we won't have 20 volts. Once it's powering this motor, it'll be a lot less. I think it's around 14, but fire this up and I'll show you what I mean. Alright, so that's 15 volts. Let's knock it down one. Not that it makes too much difference. It's quite happy running on 15 volts, clearly. Looking at the inside scale, and give or take, we're about 100 RPM on there. Don't know how clear that is. So we'll do some basic calculations quickly. 100 RPM output speed. We've got a 2-to-1 reduction, so we'll call that 200. We've got 12 TPI thread count. So if we divide 200 by 12, it gives us, if my maths is right, 16.67-ish. So we're not too far away there, so it's just shy of 17 inches per minute, so should be alright. That's reassured me a little bit, because that means that I haven't got to worry about compound drives, I haven't got to worry about different pieces of stuff, but although it'd help things, but we'll use what we've got for this project, and then in the future, if need be, we'll design it in such a way so that the threaded rod is quite easy to change. So let's have a run through, see what we've done up to now. We've got the stud, bolt, drilled and tapped, screwed onto the wiper motor with a small retaining screw, and a bracket which is going to be welded to the side of the casing. This is a little bit long at the moment, but we'll shorten that down when we know how big the casing is going to be. We've got spindle, which we've just machined, along with brass bushes. So this is also going to be supported by the casing. This will be able to run on these brass bushes. With pulley, let's slide on there with grub screw, obviously to bolt it, clamp it to the spindle. So for the motor arrangement, we've got a small spacer bush, other way, with pulley, and the secondary bush. So this is a movable centre, which is slightly wider, slightly longer than that brass bush. So when the nut comes into contact with this face, it'll bolt hard up against the pulley. So this will be a stationary item, and the whole lot will be able to spin nice and freely within that brass bush. So this has also got a bit of a carrier, slide on like that. So this will also be welded to the side of the casing, and that will screw on, obviously. So when this is all tightened up, and this is fitted, of course, we'll have the belt from the biggest to the smallest on this one. So that'll give us doubling in speed. We need to calculate roughly how far the centres are apart, so that we can drill suitably into this plate. This will be the side. This will be one of the sides. So that bush will sit in there. I've already drilled that hole, obviously. I've guessed roughly where this is going to be in contact with this side, this back edge, if you like. So I can weld them to them once this is fitted. So next job will be to weld this to the base plate and corresponding other side, so that we can set this distance. We can then alter the length of that spindle and weld these to this back wall, and then that will virtually be this unit finished. What I do need to remember to do is on this side, because these holes are both drilled in the same position, on this side I need to drill the two 23mm holes like I did in the end that retains the other end of the rails in there. So I need to mark that out, drill them two, then I can weld that to the base plate along with the other side, fit that, and weld the sidewall, tack it all in place obviously, of the base, and that'll give me this position for this where it needs to be, so I can fully weld these. I'll be able to fully weld the casing then, and we'll be virtually finished, other than the carriage, which of course we'll be using the pieces of box section and whatever pieces of scrap elsewhere we can find. Let's just have a quick look at this. So I've got this all tacked together, and I encountered a problem. When I originally did the measurements to get the position of this spindle relative to this one, I must have had it set up differently. I must have had it tacked together differently, because when I've gone to assemble it, I haven't got enough. I can't drop the motor down far enough to give me enough slack in the belt to get these two brackets welded straight to this back wall. Obviously that was my plan originally, just to weld that straight to it, but as it happens, it's probably worked out for the better, because what I've had to do is weld a little bit of extra material to the back of these to make this a single unit now, which will move independently of everything else. So my plan is I'll be able to drill through in a couple of places with some elongated holes, and that will give me some up and down adjustment, which will invariably will give me the ability to release or increase tension on this belt depending on what position the belt is in. I was never planning on having the adjustment of drive speed. I was just planning on using the DC motor controller, but by happy accident I will now have the ability to adjust the speeds on the belt if the voltage is fixed for whatever reason. So say I've only got 2 or 3 voltages to choose from. Obviously by moving these I'll be able to get a finer speed selection, hopefully. So quickly drill some holes in there. It's set for this position. I'll elongate them in the future, but I'll just stick some 8 or 10 mil holes through, a couple of M8 or M10 fasteners, and we'll be good to go. It'll be good to test it out. I'll just get this end wall to put on then, and I'm probably not gonna fully weld this. I'll just tack it together, because the other issue, and I don't know if anybody's noticed it, but because this spindle is longer than this case, this has had to be welded. Basically I've welded this in, I can't get that out now. So maybe a future design change will have this in 2 sections, or maybe I can have this drilled and tapped, or drilled and reamed, so that I can have a grub screw with a spindle coming through one end, so that I can obviously just maneuver it out. But for what it is, I don't think I'll have too much of an issue. I won't bore you with the assembly, but the drive system is all fully finished, fully assembled. I've got the rails on and the lead screw. I've made a brass bush for that end, so this is basically as assembled now. Everything seems to be working alright actually. This threaded bar is relatively straight. It seems to be running true. This spindle, there's no issues with that one. However, I seem to have picked up a little bit of misalignment somewhere on this motor. I think it's probably where this bolt is screwed onto the spindle. There may have been some misalignment when I've machined it, or more likely is it's not quite been tapped perfectly concentric to the bolt. Should have done it in the machine, but I didn't. I did it by hand, so there's a lesson to be learned there. While I had it set up in the machine, I should have just done it then, but I've got another bolt, so worst case scenario is I'll make another one, because it is just a simple case of drilling and tapping one end. But the welder's running. We'll fire it up. So there seems to be plenty of speed. I don't know what RPM this is running at the minute. Obviously it's, we could only guess based on the output of this and the step down that we got when we calculated it earlier, but hopefully this is hopefully above 160, maybe 180 revolutions per minute, which would be nice. But we'll get the carriage welded together and we'll do some proper testing of actual speed, so we'll set it running and just measure how fast it moves in the real world. Okay, so this is genuinely first go. I've not tried this yet. I don't know if the welder's set properly or anything. I've got it rigged up. I've got 2 welders going now. So I'm going to start welding, start the feed going, and we'll see what bead looks like afterwards. So that's the weld profile. Very cold, unfortunately. The welder I'm using is a little bit underpowered. I've got 2 welders on the go at the minute, and the welder I was hoping to use I'm having to use for the wire speed because the other one hasn't got a low enough voltage. But apart from that, we've got a nice even bead profile, aside from the fact that it's very cold. Doesn't seem a lot wrong with that. Relatively straight again, which is good. Okay, bead profile. Still a little cold. Probably up the wire speed a little bit just to compensate for that. But overall, I think that's a very good result. Very happy with that. Okay, so in 30 seconds we've gone 9 inches, which is absolutely bang on. I was hoping for 15 or 16 inches, but over a minute that's 18 or so inches, which is absolutely brilliant. So very, very happy with that. It seems to have been a relative success. To summarise then, very happy. Turned out better than expected. Couldn't be happier really, considering. Feeds nice and smoothly, motor seems to run well, the little gearbox is working properly, and we get a nice constant feed, so happy days. A couple of things I'd like to change in the future. This torch holder, it's not ideal. It works, but it's awkward to adjust. It's unsightly, so I may change it out, but for now it can stay. I'm also waiting for the DC motor controller. That's not arrived yet. I was hoping I'd have that plumbed in now, but such is life. I can still use a welder. I've got some adjustment on the belt, so I may use that, but it would be nice to have the motor controller. So in terms of cost then, what has it cost me? The only thing I have had to buy up to now is this DC motor controller, and that were relatively cheap. You're looking £10–12 on your favourite online auction site. It's pretty inexpensive really, and that means I can have it powered with basically any DC input up to something like 40–50 volts, which will be quite useful because you're not limited then to what you can power it with, and you get the nice fine adjustability, so we haven't got to mess about with the belts. Other than that, obviously we've used a little bit of gas for the welder, minimal of course. If you really want to factor everything in, we have used some electricity as well, a couple of quid's worth probably. Total budget, we're looking at less than 20 quid really, provided you've got the materials of course kicking around. If I didn't have the materials, I reckon you could have it done for less than 40 quid, maybe 50 quid at a push, depending on where you get your material from. If you go to someone who deals in metalwork day in day out, have a route through their scrap bin, they'll probably have enough to do this. And then your friendly scrapyard will supply you with as many motors as you can fit in your pockets. But if you've enjoyed this video, thank you for watching. It's been a pleasure having you. So from Yorkshire Fab Shop, we'll see you later.